Yeah, 3D printing. So it's similar. Why one model, not another one? I typically think of softer, curvilinear, more complex models as logical to do 3D printing, but I've seen all kinds of monsters being 3D printed of all kinds. So you have uh, just the, I don't know, like exterior flat walls with windows that are repeated. That I think it makes sense to laser cut, but people 3D print them. So you can do it as long as you can put it in a machine, and the machine will try its best, and it will do it. So, but I recommend that you look at 3D printing machines as a way to achieve, a little more complex settings that laser cutting cannot help us with. So, for example, this model will be relatively impossible to do with the laser cutting unless it was the contour option, but that would be for a mass model. So if you and it will also give you less kind of a smooth surfaces in the interior. So okay, if we go to that link, the printing, we can take a look at a little bit of the history and how the process. We have 3D model that is taken into Cura, which is the program I suggested before you download. And basically, we need to generate an STL file. This is something relatively easy because what we have to think is of a mesh that we know a little bit about and just save it or export it as STL. It's the type of file that you have under the options similar to Illustrator or AutoCAD. No? So you can read a little about this, but basically what it's going to tell you is that, hey, we need to take it to Cura and we need to prepare it a little bit there and we need to send a file from Cura into that machine. Here's where something I'm not going to be able to do with the video, and I will explain, but we probably do either on Wednesday or next week. Go to the machines on Seed Lab and take a look at it and see the thing working live, okay? Uh, Again, I think I mentioned at the beginning of the other video, it's like that you should check the Ultimaker 2 Plus as the local printer. This is the one that the school has. It has 14 of those. It also has other interesting machines, but I think for this particular assignment, we should be working with the Ultimaker 2 Plus. You have a bunch of them at Seed. You have a bunch of them at A&D. Have you seen them? If you haven't, you enter A&D, top floor, and they're close, very close to the, let's call them the back stairway. You go up the stairway, the back one. You won't see them the second you exit that stairway on the top floor, but they're right behind a little partition there. I believe there you have 4 or 5, and Seed Lab has around 12 or 10, I don't know. I believe now there's a bunch of new materials of different colors, so you just choose the different options. Typically the PLA, the type of thermoplastic polylastic acid is something that you can melt and then it solidifies after melting. So, and that's how it goes. It goes around, and this is how the machines look, okay? Once you download the program I talked about that you can find on our webpage, on Canvas, you're going to be able to access this software. So you can make a course for free, and you sign in, and you can orbitate, right-click, scroll in and out, and you will be able to select stuff once you place it here. Okay. You can also select different views if you want. It's up to you. As I mentioned before, this is like to open a file. You need to search here for STL files that we bring from Rhino. Here's if you want to add a printer. And this is the material. I recommend you leave it as it is. This is the setting for how you want to 3D print. Okay. So let's go into it. First, scale. If we go to the 3D printing material, we can take a look at this guy, and it's actually 223, 223. And because we're in America, we don't work with millimeters. We might want to say millimeters, 2 inches or something like that, and insert here what 223 is. So it's be maybe on the safe side, you go 8.5. So that's going to be a box of 8.5 inches, and then it's, if I remember well, it's 205. So that would be 205, which is 8. So we say 8 inches. You say, well, that's very small. Or what did you expect? That you're going to 3D print the entire building? Well, you can with some big machines, but it's not what we're going to be doing. We're going to do a very small thing. I recommend you have that bounding box, go to 0 and place it there, very small and cute. I would even call it something like change object, bounding box, 3D print limit, or whatever you want to call it. And that's the one you can turn off and on. So you can make sure that it fits inside. How do we do that? Well, we move this guy, we put it on the 0, and I'm going to just scale it down for now from here. Now I'm doing scale command, going to the 0, click once, go to the end point, click twice, and that allows you to do scale manually or whatever the size you want. I'm going to go exactly the size of the box. Okay, I'm going to go to the X-ray so you can see a little of what the ghost did. You can see one is inside of another one. I wouldn't go so crazily big, because that's actually relatively big. I would just be conscious of time. I will probably do 50% of that, like 0.5, something like this, I think. 50% of the overall occupation or volumetric occupation of the model. That makes sense, I think, to do. If you want to go a little bigger, it's okay, but it's going to take a long time. So be careful with that. Okay, so once you have it inside, maybe we don't even need the bounding box at all, but you can just turn it off for now. You want to have this in a 0. So what I'm doing is here is move, click here, and then type 0 and goes to 0, zoom extend, and I'm happy. You can always do bounding box again of this guy and place a couple of dimensions to be 100% sure that this is the size you want, that is not bigger than the, the volume that you can 3D print, and feel happy about it. Okay. If you're going to do 2 of them, maybe you want to do them same size or the same scale, so you scale them similarly. But ultimately, you're not going to 3D print this. So what you're going to 3D print is a mesh of this. So I recommend meshing this. So you could actually select this, say export selected, and search for our friend STL, which is here. Okay, you can give it a name. Hello, 3D print, please. But it's going to do a mesh for you. So I recommend to mesh this here. Think of how many polygons you want to use. I'm going to use the average for now and take a look at it. Think if that's good enough in terms of smoothness. I mean, again, the machine is not going to be able to do a perfect smooth. It has its own kind of texture to it. If you think it's too bulky or too detailed, you might want to mesh it again and reduce the polygons and say, this is good enough for me. If it's good enough for you with less polygons, better. It's going to be faster to 3D print. But if you need more, you can always do more. Okay, I'm going to go in the hardcore side of it. Okay, so it's a bit smoother. Probably that's what you want ultimately. You go with this one and you're happy about it. That's the first step, creating a mesh. Now, very complex models, you're going to have to clean, fix, maybe do things to it until it's perfectly in good shape. Where do you do that? Under mesh tools. All of these things here are basically how to fix, how to clean, how to update, how to do things to meshes. Okay, I think we talked about this a little bit, but not in depth. Well, I'm not going to be able to do it in depth either, but a little more yet. For example, these 2 guys in the beginning, check objects. This is an important one. This allows you to see if the mesh is good or not. Okay, if you say check, it's gonna tell you stuff about it. Um, says does not have any degenerate faces and gone. These are just terminology for parts of the message. And if all of them are does not, you're in good shape. Okay. Say geometry is a valid mesh. I'm very happy. I'm just gonna send this thing. Another option is like fix, mesh repair. This is a very important one. You can select the mesh, check mesh, and it tells you this is a good mesh, so you're in good shape. But if it tells you it's a bad mesh, you need to start clicking on the next option. It's going to tell you things such as their open edges, naked edges, non-manifold edges, and you can zoom to them and start fixing them one by one. This could be a nightmarish thing. I hope your models don't have any problem. If you have some of the problems, you go next and kind of repair, and see if you get it. We probably need to meet in class and see repairing strategies. For example, if you have naked edges, means that you have a mesh set of points that are detached. So things that you can do, you can select the mesh and fill the mesh holes. That will close any little opening that you might have. Okay, that's a good one. You can rebuild the mesh. There's too many vertices and too many polygons. You can rebuild, make less of them, more of them, whatever you need to do. You can um, you can clean the mesh normal. That could be a problem. Some polygons, little surfaces on the mesh look down and other ones up. That's a problem for 3D printing. You can unify that with this option. Rebuild all of the normals are there. All of the mesh polygon surfaces need to look in the same direction. Ultimately, you can also, you know, select some of the faces, like Control Shift, select the face. You can delete some stuff and start right clicking on the fill all holes and click the hole to close it and make sure things are what is called watertight, meaning you pour in water, no water comes out. I think because we're coming from not necessarily very complex models, I don't think we're going to have any of these problems, but I would like you to try to check the mesh and use the mesh repair wizard to see that there's actually no problems with your model. Okay, we can also check it during class how it looks. Okay, so let's say you're good. I'm going to choose that one as higher resolution. I'm going to delete the rest. I'm going to go from here and to the 0. And this is the point where you export selected STL and 3D print. Oops. And we call it, project alone. Okay. If you actually open this STL, which you can, you're going to see that this is just basically a do it. Oh, wait a minute. So I didn't export it. Let me see. Here it is. Desktop. See there, no? There's. Okay, so if you open actually that one, you're going to see that it's basically the mesh. You don't need to open it, but it's basically how it works. Okay. You will see that it's the mesh, the same quality as the mesh. has this particular language, but it's just a mess. It has a specific language we can use in Cura to 3D print, okay? Again, you don't need to open it up. So now the step is here. We come down to the software to make a Cura. We click on the folder, desktop. We select the file that we actually exported it. We open it up, and there it goes. Well, it definitely feels much smaller than what I had here. I don't know if you remember. So my guess is that I did the millimeters to inches incorrectly, the translation, but um, that's one option. Or the other option is that these numbers are incorrect. So one of the two, it's it's the situation, but you could always just go back and scale these a little bit better and fix that. But I think that would be okay. Probably a little bigger makes more sense. But let's just imagine this is the case that we're good with it. So notice there's a button here, slide. Okay, so it's a problem scale, out of scale. It might be we're dealing with millimeters and we're with inches. That's the thing. Okay, so it might be an issue, and this is one of the steps like we might have some kind of problems, is that if we're dealing with inches in units, oh, millimeters. Okay, yeah, there's a problem. Problem, Professor. I am working with millimeters in my model. I didn't check the units of my model. So you need to make sure when you scale things down that you're actually in the size of the millimeters that is set on the web page. So what I did is remember I scaled down to a box that measured this and this and this inches. What I was doing is actually this and this and this millimeters, which is obviously a huge difference. So just make sure units are precise. And if you want to go into millimeters and make this box, the bounding box of your Rhino file being these millimeters, that's going to be probably even more accurate. No? So you have units, millimeters, you create a bounding box millimeters, and you scale your model down into that box. And when you bring it as an STL, it's going to be, more, appropriate scale. So I don't think can I scale this thing? Yeah. So I'm just going to do an example of this, which you can do, by the way. You can scale it here. Interesting. So next step is how do we actually go about the settings? There's a couple of things that we need to know. Well, one of them is the strength, the infill intensity, the infill pattern, and it kind of explains every single element. So it's more about reading those. The infill pattern that you don't 3D print just the border. You 3D print very well the border, but the interior you create a specific pattern to create a fill so it doesn't break like if it was made of paper. There are different ways of filling that interior, and you can just set any of these options. Okay, you could just leave the default and change the infill. The higher this number, the longer the time of the 3D printing, because it's doing that interior 3D printing very, very precisely. But of course, the higher the infill density is, there's a stronger material. If you're going to do a 3D printing of something that is just a model to show, I will keep it in where it was. 20% is good. But if you're going to do something that really is going to work structurally in a particular design, one-to-one scale, this thing has to hold this together, I would go to the 70, 50, 60%, depending on the need. No? The shell, that is let's call it the facade of the model. So the bigger it is, the more detail oriented it is, and the thicker that layer, that shell it is. No? So I would, in general, I would keep the defaults for your first setting of models, and then learn from the results of your first test. One thing that is important is the support. If you click support, what it's going to do is create these columns of material that hold things that they're cantilevering. Okay. Some models do not need support just because of how they are, but many other ones that they have slight cantilevers, and cantilever I've been told a cantilever that is beyond what is adequate in a 3D printing model is when it goes beyond 30 degrees of that angle. So think of 30 degrees. If it starts going 45 degrees, you're going to need a column to hold that in place. Okay. Obviously, in complex models, we're not going to be able to calculate that. So what I would do is use our intuition right now for this first test. Is there a lot of material cantilever? Yes, click support. No, do not click. But you might want to revise your model if it's all cantilever. I did a drawing last class. If it's like a very small base and everything is on the top, you might want to just rotate your model and start the 3D printing from the top and end in the base. At the end, you just flip it, and that's your model. Okay, so sometimes flipping the model, sometimes rotating the model. If you want to rotate, you can do that also here. Select the model and rotate it. You can do like a 90 degrees. It's like this is very similar to how Rhino works. So you could just notice how it tells you the numbers. It's 90 degrees, and it allocates itself in the middle automatically. So it might be that your model is easier to 3D print like this. There's less cantilever. The main question is thinking about how can I avoid cantilevers as much as possible. How can I have a strong, massive base and less material above, more material in the bottom, less cantilever. So start rotating those and see what options are ideal. For example, in this model, if that's what I want to, look what I have here. This little thing floating around. I would say that's not a welcoming environment for a 3D printing process because it's going to create a support right here in the corner, no? To hold that little retarded piece. One thing I will do is eliminate it from the model. Just goodbye. Why are you there anyway? Boolean difference, goodbye. But another thing is if I really want it in my model, I will go 90 and 180 degrees and make sure that's actually in the base. That's easy to 3D print. It might create a support here to hold that corner, but that's okay. By the way, the support is something you can remove afterwards, but it leaves a little mark. So the less support you have, the better. And also it takes less time to produce it. And time in 3D printing is very important. Okay. It's going to give us an estimate of time. So you should decide on whether your infill is smaller, whether, the resolution, by the way, I didn't talk, it's a little bit smaller or bigger. Maybe you leave it in fine because of the default. But if you think it's taking too long, maybe you want to jump to normal and see what happens. Addition, it's something you need. What it does is that it heats up the bed of the 3D printing. It's warming up, so when it spills the material, it gets stuck on the base. Okay. In addition, what it does is create a first layer, a little bit bigger than your model, that serves almost like the bed of the bed that sticks. It makes sure that it sticks to the ground or the floor of that machine. So don't uncheck that. Okay, so once you're done with this, trying different things, you can slice it. It's going to think. And here it is, 8 hours and 58 minutes. That's 9 hours. It is probably something you don't want to wait. You don't have to be there all the process, but that's, I think, a little bit too much. You can play. We should aim at less than 4 hours. Even if we can do something in 2 hours, we should be happy about it. So maybe you want to reduce the scale a little bit for the first model, see how it looks. Try something a little bigger the next one. I've done models that takes 12 20 hours probably is not ideal, but because they were very big and structural, I needed to do that. But just think about that time. Um, what, regardless of this, what you do at this point is the following. You can do a preview and see how this looks. Going to show you that blue cyan color. That's what I was talking about. The addition is the bed of the bed. Going to do that first. Um, there's typically a preview of this. I don't see it right now, but it tells you how the machine is going to move around. I think it might be this. There you go. That's a preview of how the machine goes. This is the pattern that I mentioned about in the interior. That's the machine is going to do very high density, that red area in green. And then this is going to do around. No? I didn't check on support, so there's no support here. But if I had checked, I would probably see something coming here in this area because there's a cantilever. And so just be aware of that. Okay. You say, I'm good. I'm happy. Again, probably you want to check support. You save to disk. That's when I can't talk about it too much now because we don't have a disk. So the disks are this blue disk that you can find on Lab, and you can find them on A&D next to the machines. Take one there for you to take and return to where they belong. You put the disk in your machine. Hopefully you have a way to connect those disks to the machine. If not, talk to me. I have actually a connector, a special connectors, like a plug-in option. And what you do once it's plugged in, Cura understands that the disk is there, and you say save to the disk. Basically like a hard drive kind of thing. You save it to the disk, you take the disk with you, you go to the machine has a little disk reader, you put it in, and what you need to do is rotate the little knob that is in the machine, search for your file, click enter, the machine starts making noise, warms up the surface, starts the process with the printing. 1 out of 3 times maybe, or 4 times it's gonna fail. So I recommend that everybody stays in nearby the machine, takes a look at the first 2 layers. If the first 1-2 layers are good, chances are it's not gonna fail. Okay, so you can go, you're not gonna stay 8 hours, 3 hours, whatever, you can go and just return at the time that you expected. If it fails, go to the knob. There's an option for cancel. Cancel. Oftentimes starts dripping material all around. Like if it was a crazy machine, you cancel it. Maybe you clean it up, or you go to another machine, say that's not working, whatever it is, and you try it again in another machine. If you leave, make sure that you don't leave the machine working, I think after night, because I think they cancel the people in charge cancel those machines automatically. So they say this it can't be 3D printed after night. So just make sure that if it's 3 hours, 4 hours, that you put it early in the morning if it's going to take the whole day, and you leave them there working throughout the day, no problem. Okay. You might want to pass by in the middle of the day just to triple check that things are going well. And that's it. There is in every single Lab or A&D, there's a contact email. Hey, you send an email. This is not working. Can you please help me out? And they typically respond these fast, so they might even come by and talk to you and tell you what problems you might have or how long the machine is going to take to get fixed, et cetera. Okay? We're done with the machine, and what I'm asking in panel 2 is actually photographs of the models you're doing, not necessarily the models, but you can bring them to class and we can just talk about them and see how that came out about. Okay? Let me stop this.